Hello, welcome back to another video. I wanted to today to work on regular expressions in our language and see how far we could get. And I have about an hour to work on it, and we'll see how far we get. Ruby has a really powerful regular expression engine, and it's actually a separate project and originated outside of Ruby, and it's written in C, and we can just pull it in. So hopefully it will be a matter of wrapping this library in our own object and exposing some methods, and we'll see what happens. So let's just jump right into it and see how it goes. So it looks like we can clone this thing, run autogen, configure, make, and make install. We won't do the make install part because we will just have it be a part of our project directly, just as a subfolder. So let's grab this and let's go over to our project. I think I'm up to date here, just to make sure. I was working on something else. I just want to make sure everything's passing here. While that's running, let's see, we will do get, how do I want to do this? I think I want to make an ext directory and put all the extra stuff in there, or extension stuff, or external, I don't know what you want to say it stands for. We'll do that, and then I'll do git submodule add, and then that URL, and we'll put it in ext onigmo, however you say that. And we'll just put that there, and we're going to want to build it as a part of our make file. As soon as this passes, I'll jump to the make file. Oh no, bar kn should be equal to bar. You know, I'm not sure that is accurate. I wonder if that's just a fluke. Okay, there are a couple of race conditions in our tests that I haven't ironed out yet, so we're gonna just pretend like you didn't see that. So let's open our make file. And I think what we want to do is, well, you know, I don't know what it builds. What does it build when you do it? So let's do this first. Let's go into the directory, do autogen. This is essentially what we want the make file to do for us, and we'll just go ahead and run it manually for the first time, and then we'll run configure. And we'll run make. And I'm trying to pay attention to what is it actually generating here. Where is it putting files? If it'll stop scrolling, I'll look at it. Looks like it's in .libs. So what's in .libs? I believe this is the file we want to build against. So let's do that. So this file is in .libs inside of ext onigmo. And so that's exactly what we want it to build when we're building everything else. Ext onigmo.libs, and then that file. And the way we build that file with our make file is, we'll just give it a little recipe here, put a colon right there. And then let's see, cd ext onigmo and autogen.sh and configure and make. Yeah, that should do it. And then on make clean, I believe we want to cd ext onigmo and make clean. So that should do it. So if I If I run make clean, it clears that directory out, runs a lot of stuff. I run make, it should build all our Natalie stuff for our language, and then cdn and run that. Perfect. Great. Okay, so while that's running, let's edit. I was looking, actually, I'll just look at it over here. In the sample, simple? Yeah, let's go with simple. Simple sounds good. Simple sounds simple. We're definitely going to want this, right? And then our object is going to wrap this code. So we're going to have to write some functions that do this, essentially. Did that finish? Not quite. Okay, so if I want to make it again, it shouldn't do it again. Perfect. Okay, cool. So let's go to our own code, our own language here, and let's just include that. I like to put this stuff kind of separate. And we need a new type. We need a new type, so a new class. And so I'll just go down here and just as a sanity check, Regex, Regexp. It's superclasses object, right? Yep, sure enough. Okay, so I'm going to do this. Actually, let's copy nil class. It already has a new method and everything, so we'll just go down here. There's really no rhyme or reason to how I organize this stuff. It's just wherever I feel like putting it. I'm just going to put it here after hash. Feels like a good place for it. So we're going to call this Regexp and Regexp and Regexp and Regexp and doot and doop. But this is new. Okay, and that does not exist. And I might have gotten a little bit ahead of myself here, so let's comment that out. Now let's go to our header file where we have our kind of God type. Everything is a one type, nat object. And I have this that I had pre-written before I even understood how regexes worked, and I thought I would store the regex as a string with a length, but I don't think that's how we want to do it. I think what you get here is you get back a pointer to a thing right here when you do Onigmo, and it tells you right away if there's an error in compiling it. So it's pre-compiled, and we can store this object. The question is, what is this? So I think I want to look at Onigmo to see what it actually is. So let's go do that. Onigmo H. There it is. Onigmo. It returns an int. Oh no, that's not a compiled. Wait a second. It's not compiled? Reg. What is reg? Oh, this is, it stores it in here. Okay, my bad. So this is the type we want to store. Perfect. Oh, and this is an int of success or failure. Makes sense? Makes sense. So this is the type we want to store. Yeah, I think that's it. So instead of all that goopy stuff, I'm going to call this Regexp just to be right. Regex. It's got a P on the end. That's going to bother me. We're going to need this value here, and we'll stick this. Let's see. R comes after P usually. So we're going to put that there. This is this type. We don't need the struct because we only are storing one thing. Cool. And Yeah, so nothing should fail on a build right now. Oh, I should not have ran clean. Okay. I may not want it to clean that directory every time. That's going to be slow. I may want like a clean and a clean all or something. Okay, well, all these things passed. Very good. I'm going to... Oh, boy. Get back to here. Okay, make file. I don't want it to run clean on that right now. I'm just going to comment that out because I'm going to rethink this. Or I'll just do clean all. I don't think that's really any sort of standard. I'll research this on what is standard here. Or maybe I want like a clean... Yeah, I'll come back to that. That's not important. But I definitely don't want to run that all the time. Okay, so if you do string C, string new, I don't even have a string new. Surprising. Integer. Do I have an integer new? No. I have a new something. Hash map new. Oh, not that. Hash. Hash new? No. Module new. Come on. Okay, there we go. So I have this for modules. I'll just do this. Let's save this as regexp.c regexp new. Make sure there's one argument to it. This is going to call, I'll just delete all of that. Call regexp. This is going to build the actual regexp. And this is going to be args0. And for now, we'll just do nat type of args0 equals nat value string. I believe. Yes, this doesn't exist. That's fine. Yeah. Nat string. Where do we do nat string? And nat symbol. Nat exception. Array. Nat hash is here. We'll just do it right here. Nat object star nat regexp. It takes an environment and it takes do I want it to take an object here or just always a string? Yeah, let's make this take a string and then this will pass the string like that. Okay, cool. And we've got that function there. We have to put this in the built-in.h and we'll put it, are these kind of in order? I think they are. So we'll put that there. And go back to here. And now we get to build this. Natalie, copy this. Natalie C. Nat. And I had it after nat hash. How far down does this go? To there. We'll just put it here. Seems like as good a place as any. Now this is... This is where we are going to copy some code. And I'm just going to copy all this because I'm not sure how much we need. I'm just going to copy all this and then start throwing things out that we don't want to keep. So let's pull this up a little bit. Why can I auto indent? There we go. Okay, so R is, it's kind of the result. I'll say result. I like better names. Start, range, and end. that's not anywhere, and that's not anywhere. So that can go away. We're going to call this regex string just to differentiate it. This is going to be the regexp itself. Oops, I should replace all those. Regexp. Okay, so that's all those. Region is nowhere. We'll get rid of that. The pattern. So it's using its own unsigned character type. We should probably use that just to make things easier, and we'll say pattern. That'll just make things easier there too. String is not used yet, right? Okay, very good. And actually, instead of results, let's say this is error. Error. I'm just going to leave all of this for now and put an abort here. This is obviously not what I want to keep it. I wanted this to raise a real error in our language, but for now I'm going to leave that. This I need to fix the header Regexp and put this there like that. And what is this complaining about? May reach end of non-void function. That's right. So it builds this object, and then we want to store that in our own type. So let's come back to here. How do we do nat hash? Right here, right? So create a new object. We change the type. Yep. Let's do that. Okay, it's going to be the object. We're going to do regexp, which I think I commented out, but that's okay. Nat new regexp. Okay, curious. What happens if I do r equals regexp.new foo our instance variables? It has no instance variables. Okay, just making sure they're not storing anything in instance variables, any of the regular expression stuff, because that's not what I was going to do either. Nat value regexp, and then return the object. Cool. So let's go back to main C where we commented out this code. Put this back. Regex new, Regex C. There you are. This it did not like. This might bite me. This really might bite me. I don't think you're supposed to do that. I don't think you're supposed to convert a signed char pointer to an unsigned char pointer. Check if okay to cast signed to unsigned char pointer. I think I saw somewhere you're not supposed to do that. Again, I'm pretty new to C. I don't do this professionally, so I'm kind of just learning as I go. So there's a possibility that's a bad idea, but we're gonna see what happens. Okay, what have I missed? What have I missed? Oh, let's look through this stuff. So here's the pattern. And I guess this is like the end of the pattern. I've noticed this is something they do a lot in this library. They do the start and the end. So I'm not really sure why exactly, but it's something they do. Okay, so So they're basically taking the start plus the length to get the end, and default ASCII encoding. We don't have Unicode yet, so that's fine. ASCII's fine. Syntax default, I will have to look into that. Error info, that's where it stores. Yeah, that's where it stores the error info, and then this is the error number. Man, I don't like that error number. Let's go back to result. You know, naming things is one of the hardest things in programming. Let's just see if it makes. Okay, it builds. I guess we need a test. Yeah, string test. No. What do I have? Integer test? What do I have? I have test, Natalie. I have symbol test. Hash test. Yeah. We'll call this Regexp test.nat. Regexp. And what do we want to say? It can be created. That's all I care about right now. So regex equals foo. R should be a test spec. I don't actually remember instance of, or be a be kind of. I forgot how to do this. Yeah, be kind of. Okay, be kind of Regex, and that is most certainly going to fail. And Natalie, test Natalie, Regex test.net. Okay, this is fun. Okay, so our parser knows about these, but our compiler doesn't. Compiler doesn't know how to handle this literal. The parser just turns it right into a regex. That's a little surprising. I'm gonna have to convert it back to a string. That is funny. Our parser in Ruby converts it into a regex. Okay, pass 1 291. As you know, our compiler is written in Ruby because someday we want to do self-hosting. We want to be able to compile enough Ruby to compile our own compiler, and that will be a very happy day. So, so what line was it? Oh, 291. 291, there we go. When it's a symbol, when it's a regexp, we're going to say nat regexp env. This is a string, and then what happens in Ruby if I say food to s? Interesting. That is not what I want. Do I just want to inspect it? No. Although maybe yes. It doesn't escape anything. So I think I want this right here. Maybe 2. I'll just use ... -1. There we go. I think that's what I want. I want to inspect it because I want to turn it back into a string of basically what it was before. That seems right to me. Okay, so let's see if we get farther. Okay, passing car forward to parameter type converts between pointers to integer type with different sign. Yeah, I knew that. Oh, no, I didn't know that. Okay, so we should do the cast inside of here. Yeah, we should do that. So, Regex C. Let's not do it here. Natalie H. Let's change this back to just a regular character pointer. and change this one to care. And then this pattern is oops. Pot. So I should only have it there and there. Okay. Ugh. Oh. Ooh, undefined symbols for architecture. Oh, yes. I know why. Because in our compiler RB, where we pass all these flags, we want to link it. We want to change the link directory to be Onigmo path. We're going to make that here in a second. .libs. No. Yes. .libs. No. That'll just be the path. I'll make up my mind eventually. And then we want to link it with Onigmo. So this is the path for libraries, and then this is the path to link it with. And we want to go up here to Onigmo, or I mean to obj path, and we're going to say this is Onigmo path. And this is going to be ext onigmo.libs, because that's where the file is built. And we're going to try this again. And something happened. Our test passed. Fascinating. That's actually pretty surprising, but it doesn't actually do anything, right? There's not much here. We have a Regex object. Regexp. I like saying that, Regexp. So I don't know, let's celebrate that at least. So let's add all this to our index, because we have a point in time where things are kind of working. This is maybe questionable. Did I lose my yeah, this to-do note actually needs to go here. We'll put it there. Check if okay to cast signed to unsigned character pointer. Y'all, that's a big to-do. I mean, what could go wrong? You have a character that overflows. It's too big to be represented, and then I don't know. Yeah, I don't know. There's probably some conversion function. I'm not gonna worry about it. Come back. I have it to do. I even have this thing. I have a hook in Git where if you put, it's not working. Whoa, it's not working. Pre-commit. Well. I used to have a hook for this. I used to have a hook that would keep you from committing if you had a to-do or fix me, and you had to override if you really wanted to commit it. Apparently I lost that hook, so this is dangerous. I'll have to remember to come back to that. So I guess we want to be able to do some actual work with this. I could say it can be inspected. Actually, let's say describe, inspect, do. Returns a string representation of the Regex, or just chop it there. So if I do this and I say r.inspect should, right, has the slashes, right, should equal foo. Oh, I just realized something. Can I get the string representation back out of this type. Onigmo H. Regex T. Pattern buffer. Okay. Regex T. Regex T. Regex. If I could type. So, okay. So we're looking for this, which is this bad boy. Look at how big that is. So this is the object. This is the struct. Common members. Compiled pattern. Compiled pattern. Well, I'm going to say it's probably that. It's probably the P. It's probably main C. Nat define method. And I'm going to say inspect and inspect, which doesn't exist yet, but it will. Regex C. I'm going to copy this. Inspect. We're going to say we don't want any arguments. And then we want to return a string. How do we do it in hash C? We do inspect here. Oh, it's long. Look at that. It's long. Well, let's put a slash on it. No, don't return it though. What do we call it here? Out? We call it out. So creative. So creative. I've been recording for 32 minutes. And then we'll do nat string append. Nat string append, yeah. env out. Nat string append. How do we use this? Oh, it's just the string and then the other string. Okay, we don't even need env. And then what we want to append is self regexp. You know, I'm just going to do assert. I'll just do this here. Self is a regexp. Save me some headache down the road in case somehow some random object comes in here. This is the pattern. And then I want to append a character. And the way we append a character, yep, is like that. And I want to append a slash, and I want to return out. Why you no likey? Why you no likey? Pass an unsigned character derivative type. Oh, here we go again. Here we go again. To do. Okay, to cast. Okay. And then this, see, built-in H. We want to make this one inspect. And we want to make it. Make and run the test. Segfault. Segfault. Okay. Curiosity. Yeah. Okay. So what if we printf that? P equals %s new line. Oh, that's a segfault? Really? Well. Oh, Regex T pointer? Is that what I did? Yeah, it's a Regex T pointer. What did I do wrong? What did I do wrong here? Oh. Wait, I did store this, right? Yeah, I stored it. Okay. This is where we get to do a sanity check. Wait a second. I didn't actually store it. I didn't actually store the Regex here. Oh, Regex equals Regex, and run that again. And p equals foo. Perfect. Okay, we can get rid of that. Get rid of that. Get rid of that. Run this. Foo should equal to foo. Well, it is equal. What do you mean? Foo should be equal to foo. These are the same picture. You know that meme from The Office. This is the same thing. Foo. Foo and foo. Yeah? Yeah. Foo is foo. String equals out. Wait, what do you mean you don't like that? Oh, it's the wrong type. Okay. It's literally, there's no new lines, there's nothing else. That's should be equal to, it is. You're on something, code. Inspect should equal. What? Oh, yeah, well, make. Okay, just curious. Foo should equal foo, right? Right? String comparison works. Oh. String comparisons work, right? String comparisons work. If I change this, then it fails because it's different. I casted this to the right thing. I'm building a string. This is interesting. Why you no likey? Whoa. Foo should be equal to foo. Foo, 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 foo. Losing my mind. Losing my mind. Inspect. I'm inspecting it. Just have curiosity. Those are the same. But this is different. This has to be a bug in how... I don't know what this is. What is the length? What is the length of it? Length equals percent d of self Regex. No, not that. Out string length. I knew it wasn't D. It's size T. Okay. Okay. The length is 7. 1, 2, 3, 4, 5. Really? How? How is it length 7? What is the length of self Regexp P, and we'll do a sterlin. Yeah, it doesn't like that either. It's 5. How can foo, which is 3 characters, have a length of 5? They're wide characters, yes? They're wide characters. So, well, wouldn't it be 6, not 5? Okay. For size T, I equals 0. I is less than the string length. I is plus plus. And we're going to loop over and we're going to do printf. Char equals, can I do that? Self Regexp P I. There's a nothing and there's a nothing. Why? Why do you do this? Does that represent, that must not be what we want. That's the compiled pattern. Use space, allocated space, num, I don't have any other char pointers exact. Optimization info, search, exact-end, reserved, pattern buffer, escaped compile conflict. That's the only thing that even resembles. What number representation is that? 4 and a 1. What is 4 in ASCII? ASCII table. Well, we may not get as far in the hour as I'd hoped. This is what happens sometimes. A 4, I don't even know what that is. 4. What was the other one? A 4 and a 1? End of transmission. And a 1 is start of heading. No way. What if I do something more gnarly? What if I do like det star, parens, bar, and a plus sign? What does that look like? Starts with a 4 and ends with a 1? Does it always start with a 4 and end with a 1? Look at that crap. That's not what I put here. I'm gonna have to store the original string. Just gonna have to. Because that's the compiled. Yeah. Well, you know, there's been worse things. So this is going to be the regex string representation. And we're going to store that. Natalie C. And we're going to store that somewhere. Pattern equals, come on, pattern. We're going to store it there. And then we're going to pull it back out where we need it, which is right about here. Oh, I gotta go put my test back like it was. Hopefully. Oh, what? What do you not like? Expected a semicolon. Oh, yeah. Expected a semicolon right there. Okay, specs are passing, moving on, making some progress. Yeah, I mean, sometimes you gotta learn the hard way, right? So we stored the original representation of it. Here's the compiled version of it. We can now print it and inspect it. We can do this. We can say foo, bar, question, whatever. Oops, no likey that. Foo, bar, question, slash. Yeah, this is that code we didn't really finish. It'd be really cool if we could raise a real error there, right? We'll come back and do that later. Maybe not in this video. I'll come back and do it in a different video. Oh, that's at the bottom of my video. Oh well. So if we could do anything, I have about 15 minutes left. Let's see if we can do a match. So first of all, what happens if I do AST foo equal to foo? What does that look like in the AST? Oh, it's a match 3. Why 3? Don't know. But it has the regex first, it has the string. What if I do it backwards? What if I do foo regex blah 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 foo? Is it literally, oh, it flips it around. Oh, match 2. Interesting. Okay. Match 2, it says. And then what does Ruby return? Ruby return for each of these. Returns 0 for that. Okay, returns 0 for that. So just where the match happens. Let's just try to get that working, and we'll do this version because I've seen this more. That's a match 3, right? So that's what we want to match, and we'll do in pass 1 of our compiler. Match 3, it says. Match, M-A-T-M-A-S, alphabetizing. Def process match XP. It's going to look like this. We're going to skip the first thing. The regex is first. The I don't, for lack of better words, I'm just gonna say string equals that, exp. I assume that just calls. So if I have a regex like so, and I just call this, yeah, because that's a method. Well, that's easy to compile. All I got to do is nat send, right? Where else do I have a nat send? The receiver, then the method, then the args. So the receiver is the regex. The method is this. Then the args looks like so, string, blah, 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 blah. Well, that's easy. So now, oh, let's write a test. Let's write a test. Do it the right way, Tim. Don't be lazy. I'm going to say equals, I don't want that hash sign on there. Returns an integer for match. So the regular expression, let's say result equals, I'll just do this. foo, foo. Should return 0, right? Result should equal 0. And let's go ahead and make another failing test. Return nil. Turn nil for no match. Say bar. And this should be equal to nil. So both of those should fail. And they failed match 2. Didn't I just try that and it was the other way around? Oh no, I have it backwards. No, this, I'm a dork. I usually do it this way. Match, I'm just gonna do both. I'm just gonna do both. So this is a match, I'm so confused. String first is match 3. String first is match 3. String first. So this is match 2. Match 2. Okay, match 3 is string first, then the regex, and we're just gonna do the same thing. We're just gonna flip them around. That's match 3, right? Match 3, string first. Match 3, string first. Match 2, string second. Match 2, string second. Okay. Whew. Man, why was I struggling with that so much? Unknown node type foo. Right, you gotta process it. And we gotta process that. And then we're just gonna copy this down there. Try that again. Cool, undefined method. Yes, yes. Go to main. Go define our method. What in the world am I gonna call this? EQ squiggly? EQ squiggly. Because this one is called EQ, which is equal. This one's ref EQ, which is the square brackets. Oh, I don't know. EQ SQ. Oh no, EQ tilde. EQ tilde. Tilde. I'm going with it. Oh, I'm not proud of that name. Not proud of it at all. EQ tilde takes one argument. It probably takes more. I'm just making things happen. Args 0 must be a string. I'm not gonna try to deal with anything else right now. So this is where we start copying the other bit of code. We don't care about regions, right? Oh yeah, maybe we do. How much of this do I need? I think I need all of this. Okay, let's go here. Let's go all the way here. This is where we would return nil. This is if there's an error, although I don't know why there would be an error. Okay, well, there could be an error. We're not going to free anything because our GC, I think, is going to do that for us. I'm not going to worry about that right now. Oh, what have I done? Let's paste this in. Okay. Come on, let's indent that stuff. And okay, we already have a regex. The only e-info is stuff we don't need. So we're gonna get rid of all of this, get rid of that pattern. Region, yes. I'm just gonna combine this declaration here. E-info goes away. Start, range and end. R is kind of the result. What did I call it up here? Did I call it a result? Oh, that wasn't here. It was Natalie C. Yeah, I called it a result. I just like descriptive names, okay? So all of these are going to be results. End. I just don't like this style, so I'm changing it. And then start. Don't need that. Okay, string is args0 string. Ooh, don't need to cast it, I think. And this is unsigned character pointer. This is unsigned character pointer. Regular expression is self Regexp. String. Just gonna do this casting here. What do you mean you don't like it? Oh. What's the const characters towards? Well, how did they do it here? They did a link thing. They did a Sterling. Wait, where was it? Sterling. Oh, they cast it. You know what? If they can cast it, I should be able to cast it. Okay, all our warnings are kind of done here. There's an error. I'm just going to call abort like I did above. Fix me. Not above, over here. Fix me. Can't type. Fix me. We don't actually want these aborts. We actually want it to raise an error, but I don't have that error yet, and I'm running out of time. So to finish our video in about an hour, I'm going to say if the result is greater than 0, we just want to return the result, I think. Nat integer env results. I'm just going to try that. Else, if result is a mismatch, we're going to turn nat nil. We don't care about that. This is an error. This is a fix me. We're going to come back and raise something here, although I'm not sure. I'm not sure what error you can get by doing I can't even type. If you do that, what error can you get? Like an empty one? No? I don't know. I don't even know what error you could get doing this. I feel like this is never going to happen, but I guess I have to be ready for it. I mean, there's no way that is all I need to do, but I don't know what else to do. And when I don't know what else to do, I run the tests and I see what fails. Ooh, it works. It works. All our tests work. No way. And then this is the part where I go, I probably wrote the test wrong. So let's just pretend this is 0 and this is nil. Both of those should fail, right? Yeah. I wrote the test correctly. I wrote the code correctly. We now have regex in our compiler, and it kind of almost works. And so we'll call that part 1. We'll come back in part 2, and we'll wire up some of the other methods, like being able to do capture groups and stuff like that. Let's see, capture groups. Being able to do like regex replace on a string. Oh, that'll be cool. But hey, we're making progress. We got passing tests. We've got a regex object. We could actually do useful work with it. So cool. Thanks for watching. Hopefully that was informative. Hope you learned a little bit, and hope to see you next time.